And so for this topic, I really want to talk about the different APIs and authentication options you have within your applications, as well as authorization. For the first part, I have a username and password. How do I authorize that person? Secondly, how do we protect two different groups of people in your application? As part of that, though, I also want to talk on how you would access other APIs and use important protocols such as OAuth. And finally, how you would offer your application as an OAuth provider and actually let Google take care of that OAuth handshake for you. The first step, authentication options. There's really two different options you have. We have built-in support leveraging Google Apps accounts or even the OpenID through Federation. What you do is say, I want my application to be restricted to anybody that has a Google account. And that could be Gmail or it could be any Google Enterprise customer. You can also restrict your application to one Google app domain. Although that's supported, I'd recommend against doing that. It's much better to handle that in your code. Then, of course, if you don't want to use one of these built-in operations, you have custom code. You can do whatever you want inside your app to authorize people. For the built-in authentication, this is all configured when you first create your application. By default, it will list as open to all Google accounts. You can also restrict to a single domain name, but if you do that, it's restricted to a single domain, and most enterprises have more than one domain. I know of some that have at least 60 different domains. You have contractors at mycompany.com or externals at mycompany.com, and if you do that, you can only restrict this to one domain. So you're going to lose out on a lot of people in your application. It's therefore much better to leave it open to all Google accounts and then restrict it within your application. We also offer an OpenID provider that's experimental. And what this allows you to do is you can accept a Facebook account or a Yahoo account or any other OpenID provider that we accept. You can, of course, also provide your own OpenID using just code. But we provide a library that makes it a little bit easier to consume. Now, if you do specify restrict to a single Google Apps domain, that can't be changed by yourself through the console. You have to open a support ticket, which, of course, you need a Premier account to do. So if you ever have to change that in the future, you'd have to reach out to us to help you with that. If you do use the Google Accounts authentication, the very first time that a user is being asked to provide their identity to your application, they're prompted with this screen. In summary, the screen is notifying the user that we're going to give this application your email address and ask whether they're okay with that. That's all it's asking. There's nothing else, and you can't access any other data for that user other than just their email address. And it will remember it for 30 days if they elect it. Once they do this, then they're automatically entered into your application and they're good to go. Redo. Once they do this, then they're entered automatically into your application and you're good to go. You can see who the user email address is and change your application's behavior based on that. Something to point out, though, is that you don't actually have the ability to change this screen. This is provided from Google so that we can take a step back and say, look what's going on. And you can't hide it in some other login screen. When you're restricted to a single Google Apps domain, it doesn't actually prompt the user for authorization because it assumes that this is for only one Google domain. So it probably has only been hosted by the enterprise customer, and it doesn't make sense to prompt for the only application. We're working on ways to make it more seamless for enterprise customers, but this is what you have today. Some people may say, well, I don't like having my users prompted because it doesn't make sense to log into my own internal application. And we'd argue that it actually does, because they could run into the screen across the board anywhere, and there's a lot of apps out there. So it's a good opportunity to educate your users on what the expectations are and make sure they're aware of what's happening when they click on an Accept button. Within your application, when you want to restrict it, if you specify just open to all Google Apps accounts, by default, it doesn't actually prompt the users to log in, and it won't give your email address. You actually have to tell your application that this section is protected and require a login. You can do that two ways. One is through configuration files. And I have a Java web.xml or a Python app.yml, and you could also do this in code. You could actually call an API that says, is this user logged in? And then redirect them to the appropriate login page. For this, what you see is a pattern with the URL, and then we have a role name. You have one of two options setting the role name. An asterisk in Java, which means that it didn't need to be logged in. It doesn't matter which role, or it just simply says log in as required for Python. Or you can mention the role admin. This is a built-in rule that we use at Google, meaning they are listed as somebody that you've already delegated access to on your App Engine project. So that viewer, a developer, an owner, if they're listed as one of those members in your console, they're going to be treated as admin user inside of your application. So it's very easy to have an admin interface without having to build your own access control inside your application. One limitation is that you can currently have 10 developers working on an application at a single time. If you have a Premier account, you can add more. If you open a support ticket, and you have to tell us every single person you want to add, and there's going to be lead time for that. However, if you're going to develop an admin section that needs more than 10 users, or has a lot of user changes, it's probably best just to build your own mechanism into your application. But it's very simple. This is a great way to do it. Or the super admin type of interface. It's a very convenient way to build into the infrastructure. If you do decide not to use the built-in Google Accounts authentication, then you can develop anything you want to control access. In fact, there's no problem if you want to integrate with your own enterprise single sign-in. The only constraint is currently we only allow outbound connections from App Engine on ports 480 and 443. So that if you want to access your single sign-on server over some background channel, you must connect on those ports. Obviously, a lot of people use username and passwords. But if you're storing that in the data storage, use good common sense and encrypt that, or do something to make it a little harder for people to get to. And if you go through your own custom route, you would create your application as open to all Google accounts. And you just wouldn't tell your application to restrict access at any point. You just build that into your code yourself. We provide a user API. And what this allows you to do, once someone's authenticated, you can get their nickname and their email, which is usually the same thing. They have slightly different variations if it's a federated identity or not. You also have the user ID, the federated identity in federated provider. And this would tell you, for example, that they're coming from Yahoo and what the Yahoo ID is for their federated identity and provider. For the user ID, it's an identifier in our infrastructure. And in fact, a user's email address could change over time, especially with Google Apps customers. They could change that email address. Maybe they get married or something changes. In this way, if you want to use a unique identifier for that user, it might be safer to rely on that user ID rather than an email address. As well as the basic figuring out who the user is, you have a few functions. One of them is to create a login URL that would redirect that user to the appropriate login. If they're already logged in, then it would just direct them to that page and that says, allow this application to see our email address. You can also get that current user in the function as well as this current user as an admin. Finally, you have an environment variable named auth domain telling you what your application is restricted to. If it's open to all Google accounts, it would be gmail.com. If the users are Google Apps customers and they've already integrated single sign-on with the Google Apps environment, then you get to take advantage of that. It will detect that they have single sign-on, and it will redirect them to the single sign-on server and automatically authenticate them if they already have an active session. Therefore, the end user experience would be just the prompt of, do you want to allow the application to get your email address? And then they're in. They don't actually have to provide their username, and they're never presented with a Google brand and login page. It's all the single sign-on system. Here's a couple of examples of the user API. In Java, it's very simple. There's a factory to get the user service, and then if that user's null, then they're not logged in, and you could redirect them to the login user. Or likewise, if the user service is an admin user, it says true or false. So it's very simple to do this. To use this inside of your code, adding perhaps a section of code or some other function that you only want to allow admin users to trigger. In Python, it's very similar. Here I show a little bit more code where you'd actually use the create login URL method. When you create the login URL, you just tell the URL that they would be redirected to on your application after they get authenticated. Now, the more complicated topic is authorization. There are entire books in classes discussing the different authorization methods. However, we'll touch only on some important ones. I'm going to first provide a high-level overview and break it into two topics. One is the internal access control within your application. The second one is delegation, discussing how you'd either access an external third party, whether it be Google or some other entity, to access a user's data without requiring the user's name and password, as well as access a data service that you want to provide so that your application can consume that. If you don't want to provide a username and password for that user to log into your application, that's where the OAuth dance comes in, and we'll discuss that a little bit later. First one, though, is internal access control. You'll have the admin role, which we've already discussed. You also can leverage Google Apps groups. Enterprise customers that already have Google Apps are synchronized with Active Directory. Adding a user to this group will automatically grant them access to the application. It's very seamless and very nice. In your code, you would just use the provisioning API. This is a GData API, and look up this user, checking whether their email address is this group. It simply returns true or false. There is some overhead on that, so you'd want to cache the results. But it's just a fairly simple thing to do. And of course, there's nothing that prevents you from creating your own list of roles and attaching to users and using that as a mechanism to figure out who can do what inside your application. There are also a lot of commercial products that are single sign-on that do a lot of authorization. They seem great on the surface, but a lot of times they're challenging to integrate with your application. So sometimes it's just better to build your own profiles within your application, store them inside of your application. Profile meaning that this user is a member of a particular role and roles that are checked to see if they can do different functions. Why delegation? Let's talk a little bit about a story of the history of delegation. A calendaring application is a very good example of where we had the boss that delegated coordinating their schedule to an admin. At first, the boss provided the username and password so the admin could just log in as the user, but that was unsecure. Companies then started programming in this delegation concept into their application so the boss could add the admin as a delegate. But in the world where we have a bunch of different services all over the internet, it becomes more complicated because now it's not just one application you're working with and different providers, and applications need to access Google Calendar data. A very bad practice began to store the username and passwords inside of your application so it could use that username and password to log into Google and then get the data. But there's some pretty big security flaws in here. Mainly, if your application gets compromised, then your usernames and passwords are lost and they have to then be changed. And that's when people created OAuth and the delegation mechanism. What this allows you to do is inside of your app or inside of Google, you can say that I want to access a small subset of data. So give me a key that only works to unlock that small set of data, and this key is associated with the user, but it's not the same thing as a user and password. This key then can only be used just to unlock that data scope. It's much more secure. If your app gets compromised, all they can do is use those keys to access the data, and you can programmatically revoke those. And users don't actually have to change their username and password. It's a much better story overall. And that's really the gist of delegation. You can also allow third-party access to your application using this as well. The one difference is, unlike when you're accessing data on, for example, Google Calendar, you can scope it down just to a small subset of data. It's an all or nothing for your application, so you can't control a subset of data in my application that I want to expose. It's here, my application that I want to expose, and then it would generate that token for them that you could present to a third-party application that they could then use to pull up access to your application. The challenge is OAuth is not that easy to figure out the first time you do it, and there are different parties involved. In fact, we actually have a whole playground that we've devoted just to OAuth, where you can go through all of our APIs and authorize an application. You could actually step through each step of the authorization process here in the OAuth Playground. So it's a very good tool. To find it, just go into developers.google.com. It's called the Google OAuth Playground. One of OAuth's biggest benefits is its scoped access to data. What this means is that you have a bunch of different keys that correspond to that scoped access for a user. And in this case, I have the boss and the user too that both have access to, and in this case, a token that's used by the administrative assistant calendaring program. And they're all independent, so you can revoke them at any time. In this case, I have a boss and the user who both have access to a token that is used by the administrative assistant's calendaring program. And they're all independent, so you can revoke them at any time. In this case, if you revoke the boss's access from that user, that token, for that user using it, then no longer works for the user, and the boss doesn't have to go change their password. So the very first time that you as a developer are going to ask a user for that token, there are a bunch of steps that go on. I'm going to try to cover them and talk about what's created on Google's infrastructure and how that interacts with your application. The first step is a user asks the application for something for it to do for them. Let's say that pulls up my calendar, pull up my Google Docs, pull up my tweet feed, whatever it could be. You have to talk to the application server. In this case, I'll use Google as an example. The authorization server then returns a redirect to your application that you give to the user that directs the browser to Google's authorization server. It says, here's the request that I want, or I want to allow this application to access my data. And it will list clearly what they want to access. If the user clicks on, I accept this access request, then Google creates a one-time code that corresponds to this access request. It then sends that one-time code to the user. You don't have to understand the exact characters, but this is roughly what it looks like on the right side. That one-time code is sent to the user's browser. As a redirect, I get sent back to your application. You use that one-time code as a callback to Google's authorization service as, here's my one-time code. Can I access an API now? In exchange, Google will delete that one-time code and create a refresh token and an access token. The refresh token is important because in this case we're asking for offline access. The access token is returned. You want to store both the access token and the refresh token in your application. The refresh token is something you can use in the future. The access token is only good for about an hour. It will actually have an expiration, but you could take that access token and either put it as a header or just append it to the core string if that API allows it. And so every time you make a call to that API, you include that access token. Google verifies that access token, and if it is still valid, it will then return the data to your application. So now all subsequent requests include that access token. If the access token is no longer valid, you have to use the refresh token to get a new access token. Let's say your application did have that refresh token. Then what happens the next time you access that API? Well, it's pretty simple. Your application has that refresh token. It gives it to Google. Google looks it up to make sure it's still valid. If it is, then it will generate a brand new access token, send that back to your application. Then your application can use that token over and over again until it's no longer valid again. The tricky part is that at any time that access token could fail, and so you have to program it into your application handling that error. It may just be that it's expired, and if you have a refresh token, you'd try it, But the refresh token could fail, and if that happens, you have to redirect to the user, if they're logged in to the application again to do the reauthorization. If that fails, then you know the user actually revoked the token and clicked deny on that button when it has prompted them for access. So you have to handle for those cases. So I talked about exposing your application through OAuth. OAuth 2.0 is a standard out there, used by a lot of other providers, but the API is considered somewhat experimental. You can use it fairly easily, certainly a lot easier than programming it yourself. Keeping track of all those tokens and the access keys isn't actually that easy, however, so Google does a lot of that for you. You can simply say, I want someone to have a key for this scope. It will prompt the user for that access just like we prompt for our own APIs. And then it will give the third-party application that token that will work for that code. Then they'll exchange for the access token, etc. So it's not just Google invented, just well supported, so we have a vested interest in it. I encourage you to read more online at developer.google.com/appengine. Some of the best practices is that earlier incarnations of OAuth have you, as a developer, do cryptography inside your application. But the latest version, it's just that access key, and that's as good as you're using a password. And that's being sent over as a header or as a query parameter. So make sure you do it over SSL. Otherwise, if someone sniffs that connection, then you can see that user token for as long as it's good for. And if they sniff the connection that use the refresh token, well, then they have the refresh token. So be very careful in how you handle that refresh token and the access token and what connections you use to the different authorization servers. Request that the smallest scope needed possible. If you don't need Google Docs access, don't ask for it. Otherwise, the user gets this long list of things you're requesting access to when all you need maybe was Calendar. It's going to be simpler and easier for the user to understand what's happening. Request that refresh token only if you need it. Again, if your application doesn't need access offline, then having that refresh token really buys you nothing because you could still go through that dance. They call it the OAuth dance. But that handshake with the client to get a new access token won't prompt them for access if they're previously authorized that application. So you can effectively do the same thing. But if you had a refresh token, then you could increase your risk of being compromised and having a data file that can be used to access other users' data. Plus, the prompt screen gives them more warning. Store that refresh token securely. We encourage you to explore further additional useful resources in these documents, tools such as OAuth Playground, and articles.